So at this point in our design process, we're looking at the specifications. So you've addressed the fundamental design criteria, and then now we're asking, what does it do? So this is where we get into design specifications for your solution. They have to be precise and explicit, and they should describe what a successful solution would be able to do. We also need to consider features. What do the users of the product want? Constraints. What are some limiting factors? And parameters. What are the testable features? So when we think about specifications, consider the definitions. It's the act of describing or identifying something precisely or of stating a precise requirement. It's a detailed description of the design and materials used to make something. So let's start thinking about materials. Also, keep in mind our constraints, a limitation or restriction. For example, one constraint that you have is you need to be able to produce your prototype in the next few months. Think about parameters. These are the numerical or other measurable factors that are related to your design. So let's take a look at some of the design criteria just in general for all designs. When we talk about form, we're talking about size, shape, dimensions, weights. You should be thinking about these. When you think about functions, you're asking, what does it do? How does it work? You need to be thinking about how to test performance, durability. How is it going to be maintained? How are you going to standardize it to make manufacturing easy? Let's consider the example of a forklift in a warehouse. Its functions. You have to think about how is it powered, how fast is it going to go, what surfaces does it have to travel across, what should be the turning radius, what are the dimensions of the cargo to be lifted, what is the maximum load it can lift, how high must the cargo be lifted and stored. So this is an example of exploring functions. You should be asking these kinds of questions about your proposed solution. So when we're thinking about standardization, you need to make sure you cover your fundamental design criteria, that you explicitly state your specifications, list your features, your constraints, and your parameters. When you're choosing your materials for your solution, you need to consider the durability of the material, the life cycle of the product, and the environmental impact of those materials. When you're thinking about durability, you need to consider the operating environment in which your solution is going to be used. Think about temperature ranges. Are there corrosive elements involved? Is it going to be dusty and dirty? Will it be in high pressure or low pressure environments? Will there be humidity? What about vibration and noise? Vibration alone can destroy a device. And what kind of abuse do you expect from the users? I love this picture down here of a piano covered in snow. So that would be really, really bad for a piano. You also need to think about life cycle of your product. How long is it supposed to last without being repaired? How long is it going to work before it needs to be replaced or gets updated with a new version? And planned obsolescence. I don't know if you've ever thought about this, but cell phones are really good at this. So when Apple releases a new phone, they already know when they're going to take it off the market and when they're going to replace it with something else and when they're not going to support it anymore. That's all mapped out. You should also be thinking about environmental impacts. How are you going to get rid of this after it's used? One of the things I know a little bit about is in semiconductor manufacturing, it uses an obscene amount of ultra pure water. So every chip in your cell phone has probably seen anywhere from 3,000 to 6,000 gallons of ultra pure water during its production and manufacturing. And now take that and extend that over the number of phones produced, and you get into alarming amounts of water. So environmental impacts, it's important to consider. Another thing, now I'm not real big on aesthetics, but it is important. One of the videos I'll have you watch, the gentleman talks about making equipment for a hospital. They have certain expectations of what that should look like. So I would much rather it work and be ugly than be really slick and not work. So But you do need to keep this in mind, that aesthetics are important. So you're thinking about color and surface treatments and shapes and materials. It needs to be visually appealing. That's the key to the customer's hearts. So a lot of times customers may purchase something that doesn't work as well, but it looks better. Customers are hard to figure out. If your design is going to be used by people, you have to consider ergonomics, about how your object and that person's body are going to interact, and how can you make it adjustable so that it's usable by all kinds of different people of all kinds of different heights and sizes. This is really seen in the computer keyboard. The computer keyboard that has QWERTY at the top, the QWERTY keyboard that every one of you have on your computer, is designed to be as inefficient as possible. And as a result, the way that keyboard is laid out, it contributes to problems like carpal tunnel syndrome. And the idea of changing to a more efficient keyboard is difficult because we're used to this one. So it goes back to the history of how the typewriter was invented, and people were typing too fast and it was breaking the typewriter. So they made this as inefficient as possible so it would slow you down. So the obvious answer is to switch to Colmac as a keyboard. But you do need to consider this, that you need to keep people safe who are using it, and that includes repetitive use over long periods of time. Anytime you get into safety, then you are getting into the world of lawsuits. So you need to make sure you're thinking about safety and legal issues. Another thing too, you don't have an infinite budget. You can't produce something that is exorbitantly and extraordinarily expensive to produce because it's not a viable solution. You do need to have an idea of how much it's going to cost. There are very few projects in the world where the people funding it say have as much money as you want. Usually there is a budget to start with where they say we think for $3 million we can get a solution for this problem. So you need to have cost in your mind, and at some point we will go through a bill of materials where you detailed produce the cost of materials to produce your solution, but not today. Remember, when you're just putting together your design specifications and parameters, make sure, I think the most important words on this whole screen are specific and unambiguous. You should also have a client involved, so that means you need to get some input from stakeholders. When you're thinking about constraints, you have resources, which are people and equipment. You have budget, which is cash money. Time, that's always pressing. How much energy you have, the materials you have available, the manufacturing processes available to you, and things of that nature. When we're talking about parameters, it needs to be something that we can evaluate. This will turn into a testing criteria at some point. So think about, how am I going to measure this if I state it as a parameter? For example, the device must warn the driver and slow the vehicle when the car is too close to an object. So we've got a lot of problems here. We understand what they mean, but they could be more well defined. Let's look at a better option of this. Within 1 second, the device must warn the vehicle driver and disengage the cruise control when the car attains a distance of less than 50 feet directly between itself and another vehicle. So now we have very, very specific things we can test and measure.